Now that we've gone through intermediate operations, short circuit operations, given a quick overview of terminal operations at a high level, we're going to walk through each of the three different categories of terminal operations in more detail. And we're going to start with the forEach terminal operation. And we're going to use our little Hamlet program once again to search for character names. You can look at that in EX12. So the first class of terminal operations we look at are terminal operations that don't return any values at all. And there's a couple of them that work that way. And so we're going to focus on variants of the forEach operation. Here's the example. As you remember, we take the character names in Hamlet, get rid of the ones that don't start with uppercase or lowercase h, capitalize them consistently, sort them, and then for each remaining one that matched and survived all the filtering and transformation and so on, we're going to go ahead and perform some action on each matching element, which in this case is going to print it out. Okay, one per line, pretty straightforward. Notice how the println method has a side effect, and that side effect is to print something out. There is no return value from forEach. There's no return value we have to store here. We're just doing this method reference on each of the elements in the stream. Okay, so far so good. forEach is one of the rare operations in streams that can have side effects. Most operations in streams are not supposed to have side effects. Remember one of the key themes with functional programming is not to have side effects. Well, here's one that has a side effect. And here's an example of the side effect. I mean, this is an example of a side effect too, but it's a little bit mysterious. Printing to the output doesn't seem like a side effect, even though it is. Here's a more obvious side effect. What we're doing here is we're creating a results list, which is given a new array list. And for every element in the stream that got through all these other operations, we're going to add that element to the end of the results list. So this is another example of side effects, right? The side effect here is to add the element to the list. And that's perfectly valid, although I would not do it this way for various reasons. One reason I would not do it this way is that there's better ways to do it, like collect, which we'll talk about. The other reason I wouldn't do it this way is that if you do this, two problems result. One is that you have to remember to initialize this array. If you just say, list results, then it's not initialized, so it'll blow up with a null pointer exception. So that's one problem. And the second problem here, which is a more subtle problem, is if you try to make this a parallel stream, and we'll talk in more detail about what parallel streams are later. If you try to make this a parallel stream, then chaos and insanity will unfold if you try to add something to this list in a parallel stream, because you'll end up with race conditions. And the reason you'll end up with race conditions is because you've got side effects in a parallel stream, and the list collection is not thread safe. So it'll have problems. Now, you could solve this by using a thread-safe collection. So you could replace the use of the list of strings with a concurrent linked queue, and then you could add to the concurrent linked queue. And that would, in fact, quote, work by some definition of work. But two problems. Number one, you're really not guaranteed what order it goes in. So even though it looks like so you don't know what the order will be. Which isn't necessarily wrong, but it's also just going to be inefficient. This is going to have more overhead because you're going to have to acquire a lock each time you add an element to the queue, and it's just messy. There's way better ways to do this. So there's another interesting operation called forEach ordered. And forEach ordered will ensure that the operations that are performed are going to be done in so-called encounter order. So the result should come out in encounter order. I don't know whether that'll save you from the race condition problem, but the idea would be that things would be ordered. This only really matters if you're doing a parallel stream. So if you're doing sequential stream, then if you're doing this, then forEach and forEach ordered have the same behavior because it's done sequentially. It's only for parallel streams where forEach ordered actually matters. And So if you want to ensure the encounter order is just the order in which the data comes into the stream in the first place, Horatio, Laertes, Hamlet, and so on. In that particular case, then, you can force the ordering with forEach ordered. The problem there is that that will most likely be less efficient because it has to provide an order and it has to keep track of the order and so on. So in general, actually, you want to avoid using forEach and forEach ordered most of the time, unless you're doing very simple programs, kind of like the test program I've been doing here, the case study program that's very easy. And instead, you want to use the more advanced types of terminal operations, which we're about to talk about. Okay, so that's the overview of forEach and forEach ordered.